Hello everybody, and welcome to this presentation about the FLORA4COP project. In this short video, I will present to you the idea that is behind this project and how we managed to improve our machine learning techniques by using two of the AI4Copernicus services. My name is Axel Dolcemascolo, and I'm a data scientist here at the 3B company who has worked on this project. Let's start with an introduction. So who are we? Who is 3B? 3B is a company founded in 2017 and is a leading climate tech company with a young and multidisciplinary team of around 55 individuals. The company provides services for monitoring and regeneration of pollinators and biodiversity. We do that by combining cutting-edge technologies such as IoT sensors and remote sensing sensors with data analytics, machine learning, and AI. Here in 3B, we have developed the Flora software. Flora is a software that uses satellite data in order to map the flora biodiversity of an area of interest through the computation of biodiversity indices. Here is an example of this analysis for a given field, and we first start with the figure on the left, which is land cover, and here each pixel defines the type of cover that we have. And we can map this information to get the flora availability, for instance, which is related to the amount of flowers that can be found in each pixel, or the pollinator abundance, which is the number of pollinators that can be found for each pixel in this area. All of these indices give us a quantitative way to measure the biodiversity of a given area. The FLORA4COP project has allowed us to improve the Flora technology by testing new machine learning services. In particular, we tested the time sent to crop service, which is a pixel-based dataset made up of more than 1 million crop samples. And the second service that we tested is the deep network for pixel-level classification of S2 patches, which is a UNet model that can be used to classify the land cover. The first service is a dataset which is composed of pixel by pixel time series, and the data provided comes from the Austrian country as it is visible from this image. These are some examples of the time series that can be extracted from the dataset. Here we evaluated the NDVI index for the class of maize and the tile 33UUP. And as you can see, there is a certain trend which is common for all of these samples, as they are all for the same class of maize. And how did we use this dataset? We used it to explore different techniques and different machine learning models. In particular, we tested two different preprocessing of the data, one which included the full time series for the whole year, and one which instead included the PCA, which is a principal component analysis techniques that allows us to reduce the dimensionality of the data. And the two types of machine learning models that we tested are an LSTM, so a long short-term memory network, and the RF, which is a random forest type of model. And as we can see from this table, the best result that we got was with the full preprocessing and the LSTM model, with an overall accuracy of around 70%. Let's now describe the second service that we tested, which is the deep network for pixel-level classification of S2 patches. This is a custom pixel-level classifier of Sentinel-2 patches that has been developed by Thales 6 GTS France. And as we can see in this picture, it is a UNet model, which means that it has an encoder, a bottleneck, and a decoder part. And there are some skip connections between some of the encoder layers and some of the decoder layers. And this service is available as a Dockerized solution that can be executed in any environment. Now we can also see the model in action. This is a Jupyter notebook that can be used to load the model that we trained and to test its performance. And this is the area under study. It is a tile of the Lombardy region, as we can see, and it has been divided into 400 polygons. The blue ones are the ones that have been used for training, and the red ones are the ones that are used for testing. We can now also select at random two polygons from the test dataset, and we can predict the classification. After some seconds, we got the first prediction, and then we got also the second prediction. For each sample, we can see the feature that is used for the prediction. Here is just the first of the features, and it's the NDVI. In the second panel, you can see the labels, so the ground truth. And then in the third panel, the prediction of the model. And here, all of the pixel where the prediction corresponds with the label has been marked in yellow. So the total accuracy of the model for this area is around 75%. As we can see, there are features that are easily distinguishable. Like here, all the water is marked in orange and the model correctly identifies it. Here, all of the houses are in red and the model again is able to identify. All of the fields are in this yellow color and they are also identified. And some other fields types are also correctly identified. However, not everything is identified as in the ground truth. In conclusion, the two AI4C services have been really useful for us in order to improve our machine learning techniques. With the time sent to crop dataset, we have been able to test different preprocessing, namely a PCA preprocessing and a full-time series preprocessing, and two types of model, the LSTM and the random forest type of model. And we found that the combination of LSTM plus full-time series was the best for accuracy. We also were able to use the deep learning unit algorithm on our internal dataset of consolidated tiles, and we tested on the Lombardy region. And the total accuracy of the model is good. It is around 68%. However, for some main classes, it is much higher. It is around 70, even 80%, while for other specific vegetation classes, it is much lower. The analysis of these two AI4C services has been really a critical step in allowing us to expand our capabilities for biodiversity mapping in order to advance in our objective of field observation and biodiversity study. So thank you for your attention.